Hello everybody, this is your video that's going to review solving systems with two equations, which is something you did in Algebra 1. The methods you learned in Algebra 1 were substitution and elimination. So I'm going to do a brief review of each, not going in too much detail because you have already done this before, but just a refresher before you learn the other methods. So keep in mind when I say a system with two equations, there's going to be two variables. And you're going to put a bracket around them. So this is a typical system here. If there's two equations, then there's going to be two different variables, typically x and y, but they can be different things depending on what the question is asking. Whenever you solve this, you end up solving for x and for y, and that allows you to write an ordered pair x, y. That's how you should always write your final answer. So take a moment and pause the video and write down these steps here and this one example. We're going to do this one together, and then you can unpause and keep going with me here. So for substitution, just a brief reminder, and then I'll go through these steps with this example. First, you need to choose the variable that's easiest to get alone, and then you're going to go ahead and get it alone and isolate it. Then you're going to take whatever expression you are left with then and plug it into the other equation. It's very important you don't plug it into the same one. You have to do it in the other equation, or else you end up with a statement like 2 equals 2 or something like that, and you can't go anywhere from there. So after you do that, you're going to end up with one equation with only one variable, and that lets you solve for that one variable. At that point, you'll have one variable solved for as a number, and then you can plug that number into one of the equations to solve for the second variable. So make sure you have those steps written down, and we're going to go ahead and solve this one using those steps. So first step here, I have to find the variable easiest to get alone. Now notice you have 4 variables here, and what you don't want to do is try and get something alone that has a coefficient, like this y, for example. Because first you would add x to each side to move the x over here. So I'd have 4y equals negative 10 plus x. Then to get y alone, you'd be dividing by 4. And you would just unnecessarily be dealing with a fraction here. You could definitely get the right answer and do it this way, but there's no reason you should be plugging a fraction in whenever you can do a much easier job without it. So let's go ahead and deal with one that's going to be much quicker, and that would be solving for something like this right here, because there's no coefficient in front of it and it's positive. So let's go ahead and solve for this y here. I'm going to subtract 4x from each side, so I have negative 11 minus 4x. So I'm going to now take this statement here, negative 11 minus 4x, and do what it says here. Plug that expression into the other equation. So I'm going to take this, which is y, and plug it in for y right here. The whole point of doing that is so that my resulting statement only has one variable. So I took negative 11 minus 4x, plugged it in for y here, which means I'm going to put it in right here. So now I'm looking at this step here. I have one equation, one variable. I'm only looking at x's here, which means I can solve for x very quickly. So I have negative 11 minus 44 minus 16x equals negative 10. And at this point, it's just basic algebra combining like terms here. So negative 17x minus 44 equals negative 10. I'm going to add 44 to each side. 44 plus negative 10 is 34, and then I'm going to divide each side by negative 17, giving me negative 2. Alright, so now that I have x, I can very quickly get y. Typically, people say you should plug this into one of the originals. You could plug it in for here. I'm just going to go ahead and plug it into one of the originals. Honestly, it really doesn't matter where you plug it in as long as what you're plugging into is a true statement. So I'm going to go ahead and plug it into this one. Right there. So I have negative x plus 4y equals negative 10. I'm going to plug negative 2 into negative x. Negative 2 is positive 2. And now I'm just going to quickly solve for y. 12 divided by 4. Y is negative 3. Alright, so there's your ordered pair, negative 2, negative 3. I'm going to set up one more for you. I'm not going to do it all out because I think after one example it's a good enough refresher. But just to make sure you're 100% okay finding the variable. So I have 4 variables here. the one that's easiest to get alone is the one without a coefficient. So you would add 3x to each side, and that will put it on the other side. So y equals 8 plus 3x. And I'm going to take this, and I'm going to plug it into the other equation for y. The whole point of doing that is so that your resulting statement is only with one variable. So that's the statement right here. And then you could go ahead and solve for it. And again, do this one all the way out because I think one example is enough. But you would go ahead and distribute and you would solve for x. And then you could go ahead and solve for y. So that's a substitution review. Let's go ahead to the other method, which is elimination. Elimination is also a very good method, especially whenever they are both in standard form. And remember, standard form is ax plus by equals c, because it's very quick to add or subtract and do this method. Now, elimination, what you're going to do is first look at your equations carefully and see if either x or y have the same or opposite coefficients. So the number in front of the variable, are they the same? Are they opposite? If you're lucky if this happens. If they do, you either right away can add or subtract the two equations to eliminate one of the variables. So I'm going to look here and I'm going to say, okay, here are my coefficients. That's a 1 for x. Here are my coefficients for y. These obviously for y are not the same or opposite, for x I mean, but look at y here. They're not the exact same, but they are opposite. So I can right away combine them, and adding or subtracting them allows you to combine them, and then that eliminates one of the variables. The most important thing here that people sometimes mess up on is deciding do you add or subtract the two equations. Right here I have 3 and I have -3. So you need to decide, am I supposed to add them or am I supposed to subtract them? Because I want to end up with a 0. And the reason we want 0 is so that one of them completely disappears. So right here, obviously, if you want 0, you're going to add these two together. 3 plus -3 is 0. So I usually put a plus sign out there to remind myself. 4x plus x is 5x. Right here, 3y plus -3y, bam, that's gone. 7 plus 13, I get 20. So you're always doing it vertically up and down. And you can quickly get x here. So once you combine them, it's very quick to get the answer for one of them. And then you're just going to go ahead and take this x and plug it into, I'm going to plug it into this guy right here. So I have 4 minus 3y equals 13. And then you can get your last variable alone. All right. And 4 -3 ends up being your final answer. Now, this is a case where you didn't really have to do much work at all. It was already set up perfectly for you, but that typically does not happen. So this is a more common case right here. So this is when, so remember this said, if either x or y have the same or opposite coefficients. If they do, you just add or subtract. If they don't have the same or opposite coefficients, you're going to have to multiply one or both of the equations by some constant number so that the coefficients are the same or opposite. And it's your choice if you're going to make them the exact same or if you're going to make them opposite. All that determines is if you have to add or subtract them once you made them the same. And again, we're doing that to eliminate one of the variables. So right here, this is a typical example here. I'm looking at my x coefficients. I have 6 and -12. And I'm looking at my y coefficients. I have 4 and -2. You could say, all right, I want to make these the same or opposite. If you want to make them the same, the easiest thing to make them both is -12. If you want to make them opposite, you could make them -12 and +12. If you want to eliminate y right away, then you could make either both of these -4 or 4. So I want you to take a minute and think, which would you want to eliminate right away? Typically, I do the one that would make them smaller, so I would probably go for the y's because all the numbers would end up being smaller. If you were going to go for the x's and you wanted to make that 12, then everything would bump up, but really it's hardly a difference at all. I want you to pause the video and try it, and then I'm going to show you something where you can check your work because I'm going to try all the methods that you could do. So pause now and try it. Okay, so hopefully you've tried it and done the whole problem out. These are all the 4 different ways that you could possibly approach this problem. You do not need to copy this screen. All I want you to do is find the method that you did, which of these approaches did you take, and check to make sure you started it off correctly. The first two, I multiplied the second equation, which allowed me to eliminate y. And the first one I'm adding here, I'm subtracting. Notice whenever your signs are opposite, you are adding. So like here and here. And when your signs are the same, you're subtracting. That's very important that you add or subtract correctly. Otherwise, you're going to get an arithmetic mistake later on. Okay, so check your work here, and we're going to do one more problem together. And the last problem is whenever you not only multiply one of the equations by a constant, but you actually have to multiply both of the equations by a constant. So your last example, you can do this one out with me here, is negative 7x plus 6y equals 20, and 3x minus 4y equals negative 20. The only mistake I see people make whenever, if they haven't done this in a really long time, and they hear elimination, they like right off the bat start adding it together and say, oh, okay, negative 7 plus 3 is negative 4. 6 plus negative 4 is 2. 20 plus negative 20 is 0. And they get a statement like this, and nothing has actually eliminated. And they're like, what do I do now, miss? If nothing is eliminated, you didn't do it right. The whole point of elimination is to actually eliminate something, which involves making the coefficients the same. So when I see this here, I'm looking at negative 7 and 3, and 6 and negative 4. I could go for 21 here, and I could go for 24 here. I'm going to go ahead and eliminate x, so I'm going to make my x's the same. So I'm going to be multiplying this by 3 and this by 7. So now I'm going to distribute this all the way across to all of these. So I have negative 21x plus 18y equals 60, and I'm going to distribute the 7. Make sure you distribute to this constant over here as well. Sometimes people forget about that one over there. So 7 times 3 is 21x, 7 times 4 is 28, 7 times 2 is 14, so negative 140. Okay, so now I'm going for the kill here. I'm going to eliminate my x's. Got to decide, do I add or subtract? They're opposite signs, so I want to add them together in order to get a 0. So bam, those are gone. 18 plus negative 18 is negative 10. 60 plus negative 140 is negative 80. And then that would make y. 8 when divided by negative 10. And then, of course, you could plug in and solve for x. So that will involve taking your answer for y and either plugging it into here or here. It really doesn't matter. What I did is I took this right here and I plugged in for y, which is 8. And then I was able to get it quickly. So this is a hopefully good enough review of elimination and substitution, and we will be practicing briefly in class, and we're going to go to graphing and the other two methods. See you later.